Alright, for the unit review, there's a few helpful hints that I want to share with you before we get started. Most of this can be done on the calculator, so if you have a calculator, you're going to want to get it. Okay, so everything for this unit you're going to find under that calc menu. Okay, so the first one is how to find a vertex. So if the problem says find the vertex, you're going to do second, then trace, which takes you into that calc menu. So second, then trace, and then you're going to use number 3 or number 4 depending on the parabola. So for my particular example I have right now, I'm going to do max, and then it says left, so you're going to go to the vertex using the left or the right arrow, and then it's going to say left, and you're going to go left 1, 2, 3, press enter, and then go back to where you think about the vertex is and go right 1, 2, 3, enter. Then it's going to say guess, just press enter again, and that will give you your vertex. Remember that the vertex is always going to be x, comma, y. It is a coordinate. Okay? Alright, so then the next one, find the x-intercepts. So to find the x-intercepts, you're going to do second calc, zeros, because that's what, or second trace, which again takes you into the calc menu. And then those number 2 are the zeros. And remember, if we're doing with quadratic, then we have 2. So you're going to go right where the one of the zeros is, and you're going to go left 1, 2, 3, press enter. Go back to the x-intercept, go right 1, 2, 3, press enter. Enter one more time. That will give you the 0 of that parabola. And remember, for quadratics, typically you're going to have 2 times you're going to have to do this. So because I have this other x-intercept over here, so I'm going to do the same thing. Second trace, 0, go over here, okay, and then read what it says. I'm going to go left 1, 2, 3, enter, go back to where the x-intercept is, right 1, 2, 3, enter, enter one more time, and that will give you your other 0. And remember, for zeros, you're going to have a number, comma, 0, because the y value is 0. Okay, so for the y-intercept, again, everything's in that calc menu, so you're going to do second, trace, and then you're going to do number 2. Second trace, I'm sorry, number 1, which is value, and number 1, and that takes you to value, and it asks for x equals, well, x equals 0 for the y-intercept, so I'm going to put 0 and press enter. So for these, you're going to have 0, comma, a number. Oops. Okay. All right, let's see. All right, now remember, the quadratic questions are going to ask you, they're going to give you information, whether they give you the x information or the y information. So this one, it says, find a y value given an x value. Okay, so find a y given an x. Well, if they give you an x, so they say x equals 1, okay, I'm just making this up, x equals 1, well, I know what x is, just like I did over here with the y-intercept. So I'm going to go to second trace, which again takes you into the calc menu, and we're going to use number 1 for value, and then you're going to put whatever they tell you the value is for the problem. So I'm going to say 1, and it outputs what my y value is. Okay, next one, how to find the x value given a y value. Okay, so say they tell you that x equals -1. So you have to go into your y equals and put in the value they tell you y is. So in my made-up example, I'm going to say y equals -1. right? And then you're going to go second trace. And this time you're going to do number 5, which is intersection. Okay, and then notice for this quadratic I have 2 intersections, so I'm going to get close to the intersection with the line y equals -1 in my parabola. I'm going to enter 1, 2, 3. So that'll give me this intersection. So where y is -1, x is -1.30. Now I have to do that again because I need this other intersection. So I'm going to go back to second trace. I'm going to do intersection one more time. Come over to the other intersection, enter 3 times, and that will give me my other intersection. So remember, depending on the graph, you may have more than one intersection. All right, and then the last one, solving a system of equations. Solving a system of equations, you're going to put both equations into y equals. Okay, so both equations into y equals. And then you're going to do second calc, and you're going to do number 5, which is the intersection. And remember, you need to do the intersection for however many times those 2 graphs intersect. So you may be doing it once, you may be doing twice, you may be doing it 3 times. So that's for systems of equations. All right, now that we have that background information, let's answer some questions. Okay. All right, the first thing you always want to do is you want to read what the problem says. The CN Tower in Toronto, Ontario is called a self-supporting structure. It is 1,821 feet tall. Suppose you are standing at the observation deck on top of the tower and you drop a penny from there and watch it fall to the ground. The table given below shows the penny's distance from the ground after various periods of time in seconds have passed. So over here we have our time in seconds, which is going to be our x value, and then we have the distance from the ground, which is our y value. So basically you're standing up here and you drop a penny, and it's timing the distance from the ground as the penny is falling. So that's what the problem is telling you. It says find the quadratic regression equation that models the distance over time. All right, so in order to do that, first thing is a good idea is to always clear your calculator. Second plus 712. So I'm cleared. You're going to go to Stat, press Enter on Edit, and you're going to list into for X to L1, for Y, L2. Okay, so I've entered all that data. Remember that these instructions have been written out for you and given to you in class. So if you have those instructions with you, that probably is a good idea to go ahead and get those out and follow along with those as well. Okay, so first of all, it says I want to know the equation. So equation, I'm going to go back to Stat, and then I'm going to go to Edit. This particular one says it's quadratic, so I'm going to go down to number 5, which is quadratic regression. I'm going to press Enter, 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 or you can arrow down as well, and then alpha trace. I'm going to paste that into y equals, and then calculate. All right, so here's our regression. So y equals, they told me a is -16 x squared plus 0x plus 1,821. Okay? Now this 0 times x is going to cancel out, so then you can simplify it to -16x squared plus 1,821. Y equals. Alright, so the first question says, what is the distance? What is the distance? So it's asking for something in this column. What is the distance? So it's looking for y. Y equals something, okay, of the penny from the ground after 5 seconds. So 5 seconds is my x, so x equals 5. Now the reason why we did this at the beginning is because now you can look here and say, what did they give me? Okay, I want to find y and they gave me x. So you can look up here and you can say, okay, I'm going to do second trace, number 1 for value, and enter my value. Okay, so I'm going to go back. I'm going to look here. Notice that it did paste into the y equals my equation, so I already have that in there. If you want to look at the data, you do zoom 9, and that'll take you to the data. Now notice it didn't take me anywhere, and it's scrolling, scrolling, scrolling. That's because my scatter plot isn't on. So go back to y equals, arrow up once to where it says plot 1, and press enter. Now if you do zoom 9, okay, so remember your plot has to be on, and zoom 9 takes you to where the scatter plot is. All right, so back to our question. It says they want to know what the distance is, and they gave me the seconds. So we know that we're going to do second trace, and they give me a value for x, so I'm going to click number 1. And they told me my value for x was 5. Press enter. And they tell me that in 5 seconds that the penny is 1,421 feet from the ground. All right, let's look at the next one. After how many seconds was the penny 50 feet away from the ground? So how many seconds? So they want to know what x is. And it says the penny was 50 feet from the ground, which that's my value of y. If you go back up here, if they want to find a value of x and they've given you y, okay, you're going to put that information into y equals and then do the intersection. Okay, so let's go into y equals, arrow down. I know my y equals 50. Okay, so then I'm going to see what that looks like. All right, so notice that intersection right there. That line that I drew is 50. So I'm going to do second trace, intersection, enter, enter, enter. The intersection is 10.5, so at 10.5 seconds, the penny is 50 feet from the ground. All right, the last question says, after how many seconds did the penny hit the ground? Well, remember that this is the distance from the ground. So when the penny hit the ground, it would be at 0 feet, so y equals 0. And then they want to know how long did it take. So they're looking for what x equals. So we're going to go back into our y equals, and instead of 50, we're going to put 0. And then we're going to go back to the graph, and where y equals 0, that's going to be the x-axis there. So then we can go second calc, or to trace, and then intersection, which is number 5, enter, enter, enter. And that's going to be after 10.67 seconds. All right, let's look at another one. The table gives the number of pairs of skis sold in a sporting goods store for several months. Find the quadratic model of the data using January as month 1, February as month 2, and so on. So if you notice in this table they say January, March, May. So they're saying that instead of January, because you can't put that into your table, we're say January is 1, February is 2, March is 3, 4, May is 5, and so on. And then they give you the number of pairs of skis sold. So we're going to put that into our calculator. Okay, remember we do stat, edit, enter the data into list 1, list 2. So this is going to be my x, this is going to be my y. All right, so find the quadratic model for the data. That means that they want to know the equation. So I'm going to do stat, calc. Again, they told me quadratic, so I'm going to go down to number 5, enter, enter, enter. And then we're going to do alpha trace and press enter because we want it to paste into y equals, and then calculate. So my quadratic model is y equals 2x squared plus, and this is actually going to be minus 28x plus 108. Okay, it says use the model to predict the number of skis sold in November. Okay, use the model to predict the number of skis. So they want to know what y is. And they told me x is November. But remember, we can't put that into the calculator. So x being November means x equals 11, because that's the month of November. Okay, so now we're going to go to y equals. Notice that it pastes in our equation. However, we need to make sure our plot is on. Plot is on. And then this one they gave me x equals, so I know I can go to second trace. I'm going to do value. Now notice that the graph isn't there. That's because that I need to zoom 9. Remember, you always want to zoom 9 to get a better picture. But your plot has to be on in order to zoom 9. So let's go back to second trace, value. We said x equals 11. Okay, notice that we got an error. That's because it's out of the window, the viewing window that we have. So what you want to do is, if it's outside the viewing window, you want to go back to zoom, quit, and then zoom. And we're going to zoom out, which is number 3. So we're going to zoom out. Okay. Okay, so see how it expanded the view? So let's try that again. I know that I need x equals 11 because that's November. So second trace, value, x is 11, press enter. It tells me that they sold 42 sets of skis, or pairs of skis, in November. Alright, and then let's take a look. In what month were the fewest skis sold? Okay, if you look at this, fewest skis in this parabola, the fewest skis, because x is going to be our number of months, and then our y is going to be the number of skis sold. The fewest skis is going to be this point right here. And we know that that is the minimum. And we know that everything is going to be in our calc menu. So second trace, we're going to do minimum. All right, now remember we have this left, right. So I want you to go down to the about where you think the vertex is, and then you're going to go left, 1, 2, 3, press enter. Go back to about where you think the vertex is. Go right, 1, 2, 3. Enter, guess, enter again. So the minimum of this parabola is x equals 6.999, y equals 10. So 6.999 we're going to round to 7. So 7, only 10 pairs of skis were sold. Well, what does 7 mean? 7 means July. Because remember we said 1, 2, 3, 4. So 5 is May, 6 is June, 7 is July. So in July were the fewest number of skis sold. All right, let's keep going. The table below lists the total number of estimated AIDS cases by year of diagnosis from 1999 to 2003 in the United States. Use a scatter plot to visualize the data. Use x equals 0 to represent 1980. So 1980 equals 0, 81 would equal 1, 82 would equal 2. So 1990 would be 10. Keep going. 1999 would be 19. 2000 would be 20. 2001 would be 21, 22, and 23. So the best thing to do is convert the years if they tell you that x represents a certain starting point for a number of years. Remember, this is not for every single problem. You have to look for if it tells you that information. Okay. First part, find the quadratic regression equation that models the number of cases diagnosed over time. Okay, so it tells you quadratic regression, which means we're going to need to put that into the calculator. Okay, remember the first thing, you're going to go to Stat, press Enter for Edit, Make sure you enter all your information, make sure that everything matches up. And then they want the quadratic equation. So quadratic equation, we're going to go back to stat calc. Quadratic again is number 5. Enter, enter, enter. Alpha trace to y equals. Okay, so here's our quadratic regression. And I'm just substituting in 345.14 x squared minus 14130.8x plus 185,431.71. Okay, based on the regression equation above, what was the likely number for cases diagnosed in 2006? Okay, now remember that this is x and this is y, so they gave me x equals 2006 and they're looking for the number of cases. So remember in y equals, it pasted our equation, but you need to make sure you turn your stat plot on, and then if you zoom 9, that will take you to where the scatter plot is. And from our first page, we know if they give me a value for x, I'm going to go into the calc menu by doing second trace. I'm going to do value, and value is 2006. Okay, however, that's not going to work because remember that we changed these into 19, 20, 21, 22, 23. Okay, so 2006 would be 26. So I'm going to use 26 in the calculator. And it gave me an error. Remember, if it gives you an error, you have to zoom out. So zoom, you have to hit quit and then zoom out. And then press enter once. Now let's try it again. Second calc, value is 26. So there were 51,347.49 estimated cases. All right, and then based on the regression equation, in what year was the predicted number of AIDS cases 48,000? Okay, so this time they're looking for X, and you want to know, they tell you that Y is 48,000. Okay, if that's the case, if they give you Y, then you have to go into Y equals, arrow down once, and put in the value that they give you for Y. Okay, and then if you go back to the graph, it's going to show you, okay, it's going to show you that there's two intersections with this. So we're going to go ahead and list both intersections. So intersection second trace number 5, and what you want to do is you want to move up to where the intersection is, because you're going to have to do this twice. Okay, and then press enter 3 times. So we have 15.9, so I have 15.9, but remember 15, if we look at this chart right here, 15 is going to be 1985. All right, but remember we have one more intersection, so we're going to do that again. Second trace intersection. I'm going to move over to the other intersection. You've got to get close to it in order for it to tell you the intersection. Okay, and then enter 3 times, and that's going to tell you X is 25. So where X is 25, we know that that is about 2005. So you have 2 answers for that particular problem. Okay? All right. Next thing for regression, it says find an equation find an equation of best fit for the given set of data points. So this one they don't tell you whether it's quadratic, they don't tell you if it's linear. Luckily, those are the only 2 things that we've done so far. So what I want you to do is I want you to clear your calculator, second plus 712, gets rid of everything. We're going to go into stat edit. I want to put this first group in. Now remember that these are all X's here, so that's what I'm going to list in L1. Negative 1, 2, 4. And then over here, negative 12, negative 6, negative 12. All right. So now you don't know if it's linear or quadratic. You have to look at the data to tell me whether it's linear or quadratic. So I'm going to go into y equals, I'm going to turn the stat plot on. So I want to see what the data looks like. Zoom 9. That to me, because there's a point here, here, and here, that looks like it's quadratic. So I'm going to use quadratic regression for this one. Each time you're making a judgment call. So stat, calc, this one I'm going to say is quadratic. All this one wants is the equation. So y equals negative x squared plus 3x minus 8. Okay? Then you're going to go through and do that again. You're going to go to stat, edit. Remember to clear, you can clear, arrow down, clear, arrow down, and put the next set of data in. Okay, so I did that. So remember my stat plot should be on, which it is. So zoom 9, we're going to take a look at this. Notice that it's going kind of curving down, it looks like. So I'm going to say that this one is also quadratic. Okay, and that one is y equals negative x squared minus 4x minus 8. All right, and then let's do the last one. My data's in, so then I'm going to go to zoom 9. And this one definitely looks linear. There's no curve with the points, so this one I'm going to say is linear. So I'm going to go to stat, calc. This time I'm going to do linear regression. And that one is y equals 4x minus 4. Remember, each one is a judgment call. You have to look to see if it's going to be quadratic or linear at this point. And that's it for this video.